So, what we decided is to do a presentation for technical people to show them what are the reasons why managers should decide to go IPv6. Okay, so that's a short overview. I look at topologies and corporate cultures because that's one of the key points, what makes the difference, you know. So you have, depending on the corporate culture that you have, you will choose different reasons. And then why should your boss spend money on IPv6? And we have a choice of technical reasons and we have a choice of other than technical reasons. So how do I convince my boss? And the answer is, it depends. And that's the best paid consultant answer that there is. And even better, it's usually true that it depends. Because it always depends, as I said, on the perspective that you have and at the context within which you ask the question and on the fact of who asks the question. So the answer is it depends. If he is your boss, you may be lucky. Because probably you don't even have to convince him, right? So, but there are other types of bosses. So I don't know your bosses, but they may fall in one of these categories, like the everyone's pal and never takes a decision, or the self-promoter, or the clueless and overwhelmed. You may just give him a good reason, or overpaid, you will give him a good reason that he will get even more salary if he does IPv6. The roadblocker may be a little difficult to handle. The overwhelmed, you just tell him how much easier his life becomes if he does IPv6, it may work. The egomaniac, you just make him look really good if he goes IPv6, right? And he'll buy into that. So, and you even may have just a nice boss that sees the point and just decides to go IPv6. So what I offer you in the following presentation is like a set of reasons why somebody should be deciding to do IPv6 and spending money and resources on it. And I just offer them, they come from my consulting experience and from the questions that I get from customers and from the things that I find when I discuss issues with customers. So I offer them on a silver platter to you, and you just choose the ones that you can use in your environment or with your own customers. So I always start out with saying that this is all about the big context. Right? If you look at the question of IPv6 in the big context, and if you have heard all these morning presentations of the current situation on the market, then you know that IPv6 is simply about the continuation of the internet. So, and as Bruce said, you know, the internet is the killer application. So that's basically it. Now, you know how the internet emerged. Nobody ever sat down and created a business plan for the internet. There were some freaky guys, they developed cool protocols, and somehow it happened that the world took it on, and we have all together created what today is the internet that we know. So it's been a global collaborative creation. Now, because we want to evolve the internet and make sure that it can serve us in the future with all the increased demands, each of us has to simply contribute his part. We all take profit from the internet. We always also have to contribute our part to the internet. So this is basically one of the main reasons why we should promote IPv6. So you see, it's the evolution of the internet. IPv6 leads us into the next generation of the internet protocol. And evolution never has a business case. Evolution simply happens, and evolution always requires investments which have no direct business case. So when we change from using horses for our travel to using cars for our travel, we had to build many roads. There was no business case in building all these roads, but we've still done it. Otherwise, we wouldn't be able to handle all the billions of cars driving around today. The horses had created some horse dung issues, and trend analysts had predicted that mankind would drown in horse dung. It did not happen because we created the car. So with the car, we have created some new issues, and we'll eventually have to solve them in the future. And by the way, this IPv6 car down here, that is also an evolution, because it's the prototype of the future networked car, and it's the car that Jordi mentioned yesterday in his presentation. It's a Renault that was built together with Cisco. and it has a Cisco router in the back with a mobile IPv6 implementation. So it's more than just a sticker on the car. So that's where we're going. The car just representing lots of new devices being connected with always-on connectivity. So let's have a closer look at the business case. IPv6 is an upgrade of your infrastructure. If you integrate IPv6 into your network, you will just make sure that your network performs on the state of the art so it can carry latest services. There is never a direct business case for infrastructure upgrades. You always have a certain part of your budget, of your cost, allocated to maintaining your infrastructure in order to run the services that you need. Now, your real direct business case is always in the services that run on top of your network. But if your network is not state-of-the-art, you will lose quality of your services. So it's an indirect business case. So if your manager really wants to save costs, the best thing he can do is turn off the network. That will save a lot of cost. And it's also a very good security mechanism, I can tell you. So the business case is for your boss in what he loses if he does not invest into IPv6. Immediately he will have no loss, but in the mid and long term he will lose a lot. And also one of the excuses that we hear a lot is, oh, our customers, they don't ask for IPv6. And in most cases the answer is customers will never ask for IPv6. They will ask for services, like grandma for the TV, right? So, technical reasons. I don't want to go into a discussion of technical features. That's not part of this presentation. We have enough of these, and you probably all are very well aware. The technical reasons for the manager to choose IPv6 is that he needs to understand new things that we have with IPv6, such as the address space expansion and especially the support for extension headers. Because what your boss needs to understand is that when newer applications coming out to the market using those extension headers, that those applications will never run in his IPv4 network. So it's sort of important that they get that they really lose something in the midterm if they can't do it. Or, for instance, if you have applications that are based on the extended or advanced mobility functions of mobile IPv6, they won't run in an IPv4 network either. And there may be some others. So make your boss aware of the new features that IPv6 brings and why this will create a problem at some point if it doesn't integrate it. So when it comes to other reasons, we have the address space issues, and I do not go into much detail because this morning this topic was well covered. What I want to show here, though, is that we have the world population in 2010 is approximately 6.8 billion people. The internet population in 2010 is approximately 1.9 billion, so almost 2 billion people. This represents approximately 28% of mankind, right? So even though we're talking about address space scarcity since more than 10 years, only 28% of people have internet access today, and we have not even started talking about all the devices that will be connected in the future. Now, if I compare my statistics, the internet population back in the year 2001 was at approximately 300 million, so that's 0.3 billion. And so we see how much it increased since then. So the internet growth is an incredible number. It's an average number of 444% as an average for the world. And the highest rate is in Middle East, Africa, and Latin America, as we heard this morning, and there it's over 1,000%. And I will show you why we care about this. So it's inevitable that we introduced a new protocol in order to maintain our networks and the internet in the future. Now, this is the statistics. We're down to 12/8, and we have heard about this in the morning enough. So Tony Hain has explained in detail when the RIR pools will gonna run out, and you have the link here where you can follow all these numbers. So this is a slide that I like. This is my way of looking at trying to grasp how big is the IPv6 address space. If this is the number of IPv6 allocations as per January 2010, and we count it in /32s, and it's approximately 140,000 /32s that were allocated in January. So I was thinking of how much is this? 2010, January, we thought this is an early time. We're not really doing IPv6 yet, so it can't be too much. And then 140,000 times /32 sounds like pretty much. So I was figuring that one single /32 actually represents more IPv6 networks than the whole IPv4 address space has addresses, because it's 32 bits, right? And with IPv4, we have 32 bits, but that includes the host ID. So that's amazing. I mean, that's incredible, 140,000 times. Now I said, let's go and have a look at how much is this of the total available IPv6 address space. So we figured, and I've actually then found the link on bgpexpert.com. This represents 0.02% of the IPv6 address space. And that's not the full address space. That's only the 2000/3 prefix. 47%? I would have to go to another website. I don't have it. You can go to the 66S website, and then you see a breakdown on country of what prefixes are allocated and how many of them are visible. That's a pretty interesting site. So this is how big the IPv6 address space is. Now, I said you care about the internet growth rate, and this is why. You have a short list, like how did the online world population grow? In 2001, we had the 360 million. In 2005, this was up by almost 3 times, up to 938 million, which represented the global penetration rate of 14%. In 2009, we're up to 1.4 billion, which is 21%. And in 2010, we have the 1.9 billion that I just mentioned. So this is 28% penetration rate. Now, right now, almost 100% of these users are on IPv4, right? But the moment that we run out of IPv4, new users coming to the internet, they may possibly be IPv6 only. So from that moment on, we care about the growth rate, because the growth rate tells us how big could the percentage of IPv6 only users be. So if you look at the jump from 2009 to 2010, it was about 500 million users added in 1 year. So if we just would assume a conservative assumption of a linear growth rate, 500 million per year, we would be up to 3 billion users in 2012, a time around which we think that most pools will be exhausted. So that would mean that by the year of 2015, we would have at least 4.5 billion new internet users. And of these, many may be IPv6 only. Many will use transition mechanisms, we don't know, but chances are that it's going to be a high percentage, or hopes are. So if you still want to have the business case after all these things, I mean, they show that we just have to go there, right? So the business case is, if you don't integrate, you will have extra cost and risk due to an overaged infrastructure. You will not be able to integrate new applications and services that make use of the advanced protocol features. You may possibly lose markets and customers due to outdated services and limited global connectivity. So the business case is what you lose if you don't do it. So when you look at ways to integrate IPv6, there are several ways that you can go, and for every enterprise, the way to get from A to B is a different way, and what you need to do is have a look at your landscape, at your services, at your network, and then figure out what your goal is going to be, where you want to be in 5 to 8 years, and then find a path to get from where you are today to where you want to go. So while you do all this, you will have to take some basic decisions that will be important for you, because you're going to live with them for a long time. So you should take your time. You have to start working on it. You have to take it step by step, break it down to doable steps, and this is how you do it. I'm not going to go through this slide in detail with you, because we're going to have other presentations that tell you about how to go about the whole thing. What I want to say with this slide is there is a lot of work ahead, and you should take your time for planning. And all the red lines here are the lines that create a lot of work time. If you have to assess your network and see which of your devices, application services is ready for IPv6, it takes some time. But it's also a chance for your people to build internal expertise on IPv6 if people start working with the protocol. And also it's very important because if you buy new stuff like new core routers, new firewalls, you will have to be able to make specific requirements as was to RFCs you need to have supported. And in order to be able to do that, you need to have an idea of where you want to go and what your concepts look like. So there is a lot of planning ahead that you need to do before you're actually able to deploy IPv6. So one thing that you will create if you integrate IPv6 is a new IP address concept, right? And you should take your time. So from talking to many different people who have done it, usually your search try is getting to a state where you can actually use it. One thing that you need to get rid of if you do this is your conservative thinking of how to plan IPv address concepts in an IPv4 world, right? It's in your cells to be very conservative. Now you have to get rid of that before you build an IPv6 address concept. So this will take some time too. And you have many other different concepts that you may be building during this. So you have a new address concept, you have a new network and routing concept, you create new security concepts, you create new management concepts. If you take enough time to do this carefully, you will be able to take all your experience from maintaining and operating IPv4 networks into this, but not just copy these old concepts, but combine them with the new options and possibilities that IPv6 offers. So, and then you should use the projects that are ahead of you. So this is a list of projects that I usually hear when I ask my customers, what will you going to be doing in the next 3 years? They move data centers, redesign DMZ, implement VoIP, migrate to Windows 7 and Windows Server 2008. These are all milestones. This is where you save money. If you take IPv6 into account while you do all these things that you're going to do anyway, you save a lot of money because you only touch them once. If you do all these things with no concern for IPv6, you will just touch them again when you do IPv6. So there is a high cost factor in doing this, and customers slowly start to understand this. So this all only works if you do it while there is time. And if you don't plan to do it the quick and dirty way, because you're going to live with it for years. So this is not something you look at with a 1-year perspective, right? It's a 20, 30, 40, whatever year perspective. So what are the reasons your CEO could be running out of time? Number A, if he runs out of IPv4 addresses, and he may just think that he has enough, but suddenly need an application that needs a lot of more addresses or grow his network. It's the only way to support dual stack if he has enough IPv4 addresses. Or if somebody just wants a new application that requires IPv6, that creates a driver to do it. Or simply because you want to be connected to the internet because of the growth of the internet and the IPv6 only user community that will be growing. So as a summary, the golden rule set is here: never touch a running system. Don't wait for a flag day or killer application and take your time for the new concepts. Use the natural life cycles of your products and align the integration of IPv6 with other projects that you have, right? So that is the summary for your boss. So here's my ultimate killer application after the internet, is if Microsoft released a PowerPoint version that has very advanced functions running in an IPv6 network, IPv6 would be the main topic in the boardrooms starting tomorrow. So, anybody from Microsoft here? No. So when is it time for IPv6? Now. Thank you very much.